Hello and welcome back. Today on the bench is this low opta radiogram, X-radiogram that has been giving me so much grief over the last few months. It's now finished, but before we get to the end bit, we've got to go back in time to carry on with the winding of the transformer, the mains transformer, and other massignations and fettling that we've got to do before we get there. We're at the end of the primary winding now of this small transformer, and we're sort of in the middle where we don't want to be. I've gone over a bit, I've gone over by about 30 turns, but I'm not too worried about that. So there's different ways you can terminate this. If this happens, you can just go poof straight over, but what I'm going to do, I'm just going to do this by hand, and then I'm just going to shove it over a bit until we get to here. So just put a few more turns on, not a big problem. So that's that cut off and terminated. I'm going to use this new tape that I've got. It's like a glass fibre tape, it's thicker than your Captain tape. So I'm going to put that over the width of it here, and then I'm just going to put a bit of Captain tape over that to keep that isolated from the secondary. I was about ready to put the secondary on, and I noticed here it slipped down the back. So what I'm going to do, I'm going to go and get me highfalutin, what is this stuff called, varnish. I'm going to put a varnish and go around the edges there. See if you can see there, look, we've got a bit of a gap there and all. So let's go and whack some of that on to make doubly sure. So that's the secondary winding on. For some reason, I didn't think it was going to go on. For some reason it wound a lot of turns at this end. So when I looked at the space left here, I thought, oh my goodness, we ain't going to have enough room. But what I did, I altered the space in, so it went boop, boop, quite a few turns on, sorry, quite a few layers on that bit, and then anyway it's worked out alright. We've got enough room for the heater winding, which is this one. Now it's got 73 turns on it according to the program, Servo Kleik's program, but I've got about 20 less than that, so we'll see. So I've got to wind up by hand, so turn all this off, wind up by hand, and then get the laminations back on. Well, after I've insulated it with tape. Well, that's the heater windings on, hopefully. So I'm going to leave this uncovered with no tape on it until we put the laminations on and then see if we've got the correct voltage out. So put the most of the laminations on, and we're short on the heater. Got 11.4, that's unloaded, and on the HT secondary we've got 208, which might also be a bit short. Let me just work that out. Well, I've put another 10 turns on of heater windings, and we're still short. I would have thought that would have been more than enough, but luckily I've got a bit of wire left over. To save sodding about, I think I'll just try and wind around the core. Anyway, it's late-ish, tea time. That's worked out okay-ish. Still a few things to do. Sort it out in the morning. Alrighty raw. Where we are the next morning, put a few more laminations in and put a few more turns on the heater. We've got 13 volts at 1 amp. That's roughly our specification. So use the 12 ohm resistor, and now I'm actually testing it on the valves themselves because I find that gives you a far more accurate reading. We're over here on the meter there. Try not to jiggle about too much. Where are we? Come on. There. It's going to go up because the when the heaters warm up, the resistance goes down. That's not too bad. We're just a little tad over. So I'm happy with that. We're not buzzing. Alright, slung the transformer that we wound back in the old thing, chassis. Blah blah blah, connected it up to a load of voltages. We're only getting 210 volts. But we've got a big drop-in resistor in there. Okie dokie. So that might need taking out there. So anyway, it lives, although it lives distortedly. So the next thing to do really is to take some voltages, DC voltages, and see where we are. I'm going to go and take some voltages and then see if we can get clean the output up a bit. Well, here we are the next morning after testing this PCL86 single-ended Class A amplifier out. We had a couple of 270 ohm resistors in series. What's that? 250, 500 and 500 and a bit ohms altogether, which we had before we reran this transformer because it had too high a voltage. We've got a 33 ohm, which will give us a 3 dB cut at 50 hertz. It should be really 1k-ish to get the 100, a really good 3 dB 100 hertz drop, but that will drop too much voltage. That gives us about 240 volts on the anode of said PCL86. Everything was working ish, it works, but we had far too much gain, so I had the cathodes of the triode stage bypassed with these capacitors. Too much gain, and what I found was when I was trying to apply negative feedback, this is a 10k variable pot, precision pot, blah blah blah, 10 turn pot, so basically adjusting that to, you know, get good frequency response with stability. I nearly had to bottom it out to 12 ohms before the negative feedback was working, which I couldn't understand at all. I don't know what's going off there. So I took off the bypass caps on the triode stage, which obviously reduced gain a lot, but it's reduced it a hell of a lot. So now I'm having to put in over a volt to get anything out, which I will now show you. So that's our output, and that's the output in RMS. So we're actually getting, it's not an amplifier, it's a de-amplifier. We're putting 1 volt in and we're getting let's call that 890 millivolts out, which is oh Lord of mercy. It goes from the sublime to the bleeding ridiculous sometimes. There we go. We've got 900 millivolts. What distortion. Ooh, 1.8, and that's without any negative feedback. So yes, we're not brilliant, is it? Right, I've partially bypassed the cathode and we're still only getting 900, don't forget, we're still only getting 900 millivolts out. However, I'm not worried about that at the moment. What I've done now, I've got 3.5 volts going in, I've got 2.9 coming out. Nice sign out. We're applying negative feedback and we've got a lovely total harmonic distortion levels. Blah blah. Right, let's have a look at the frequency response. 10 kilohertz, 2.9 still. Amplitude 20. Oh shite. So frequency 20 kilohertz. Little bit of a drop there. Frequency 30 kilohertz. Still a little bit drop, but frequency response is good. Let's go the other way. Frequency 100 hertz. Yeah, right, we need to, and that's still the same. So what I'm trying to get at is our frequency response is good. Our total harmonic distortion is good. We need to up the gain of this triode section. Now then, you know I mentioned before that I was having to apply loads of negative feedback and getting very little results. This is because, I hope you can see there, look, this is our triode. I've got a 47k anode resistor to keep the gain low. All this on the front end there. Some of this is a bit wrong. So this is how I had the coupling cap, decoupling cap before. That was coupled to ground, you see, which is wrong. Hence you were getting no discernible difference with negative feedback. What it should have been was this. So I'll go and do the load lines for the triode section, redo them. Might have to change this, hope not, and then we'll rejig it and hopefully get more gain out, and we should be right. Right, well I upped the anode resistor to 220k, and as you can see we've got right.
And reds and golds and yellows, where the colours in the dawn.
Right, that's for music in, with negative feedback. And this is without negative feedback.
On Jersey Thursday.
Well, the bugger works. Right, I'm going to get flagged for that anyway, never mind. I'm not monetized, so fuck it. What can they do? Not show it in Cuba, but they're not allowed to fucking watch it in Cuba anyway, so poor bastards. Well, yeah, they may be spared from these dribblings, but never mind. Anyway, I digress, as per bleeding usual. Yeah, two valves in there, bloody blah. Put the little panel that I knocked up on there. What's that called? It's called an RCA in. So that's in there, but it's going in the MIT decoder. Input, output, whatever. Yeah, on off switch, bloody blah. I'm actually waffling because I'm quite chuffed with how it sounds. I'm quite surprised how it sounds, to be honest. Let's go and bung some reggae on and sample the bass. Well, I've just been listening to it. I've just been listening to this for the last 5 minutes. It sounds really quite nice. It's got no negative feedback on it. It's just, yeah, I don't know. This amplifier, it's like all amplifiers, building all amplifiers. I've gone from total despair to abandonment of the whole project to having another go, and yeah, I don't know. And the feeling when it actually works, it's a good buzz, you know, especially when the bugger works and it actually sounds alright. I am quite chuffed with it and very surprised, really surprised, because I thought it would sound shite. Well, it just goes to show you, you know, have faith in your skills, have faith in your fettling ability, and crack on, have a go, as they say. Well, I think that's all for now. I'm going to go and have a lie down and recover after all this excitement. Take care of your sends out there. Ta-da for now.